start with the class today. So in the last class, we had done a little bit on network security, right? That is, what is network security and why do we need it? All right. So I should not have to tell as to why security is required, because you all know by now that why security is required over the internet. Okay. So the one that we actually need to know is how do we provide security? And for providing the security, what we need to know is how are or what are the different ways in which the hackers can actually hamper or tamper with the security of the network. Okay, so let's see how the attacks happen. Okay, all right. So this is what we had ended our class with in the last class. That is, what is packet sniffing? Okay, so basically, packet sniffing is nothing but intercepting a packet. Okay, and this happens in cases where we are broadcasting the information. All right, so broadcast media, as I had told earlier also, that mostly wireless and ethernet, they offer broadcast as a way of transmission. So in these networks, sniffing is more perceptible. All right, so what can be done? So if there is a bad guy who's C here, and he wants to sniff the packets. So what can be done? If there is a communication that happens from B to A, that means this is a packet, and it has source and destination addresses in its header part, and the payload part is there. So what C will do is, because it is having a connection between A and B, it will simply intercept that packet which is going from B to A without any one of them knowing. Okay, so essentially you are transmitting some message to somebody, but there's somebody in between who's simply recording all the data that you are sending. Okay, so that is known as packet sniffing. All right. So suppose, so most of the time, suppose you are transferring a password. Okay, you are just putting your password in some website for logging in, or it is a bank password maybe. So if there is a sniffer, he can sniff that packet, and then your data will be compromised. Okay, now this is one thing that I had told you also, that in the end of the chapter in the book you will find out a lab which is on Wireshark and which actually talks about packet sniffers. Okay, so if you are interested, you can try that too. All right. Now let's get to the next type, that is fake identity, or which is known as IP spoofing. That is, you are injecting a packet into the network which is having some false source address. Okay, so basically you are behaving, or basically you are taking somebody else's identity, you are posing as somebody else, and then taking up information from another host. Okay, so let's see what happens. So same diagram is here, like this is packet C. Okay, sorry, this is host C, and this host C is trying to spoof on the information that A has to give. So what it will do, it will simply send a packet to A with the source address as B. Okay, it will say that it will not say its real identity. It will just pose as that it is host B. It will send a packet, and then when A gets to know that okay, this is source B only, so it will simply send that information. Okay, and when it gets back, C definitely is the one who's spoofing, so he will get that information, and um, which is basically a compromising position for A and B both. Now the next one is denial of service. Okay, so as the name suggests, denial of service is a scenario where, due to some unfortunate event or some compromise that has been done to the network, a service that would have been given in a normal scenario is not being given to a particular host. Okay, so for example, um, what will happen is an attacker will basically make the resources unavailable to a legitimate user. Okay, and thereby when the legitimate user tries to access the medium or tries to access the resource, then he will not get that resource because the resource will be unavailable for him. Okay, so for example, let's check this. So therefore, let's see that this is the target. Okay, this server is the target. So now these are the hosts which actually are bad ones. Okay, they want to take up the resources or eat up the resources in such a way so that the legitimate users um, who are not the bad guys basically, so the legitimate users will not be able to get the resource or access the resource. Okay, so for example, these are so this can be done with the help of botnets too. So these are botnets. Okay, uh, so now what these will do, that these will basically send a lot of packets to the target. Okay, so target is this server, so it will send a lot of requests. Okay, so request packets will be sent to this target node, and what will happen, the target node does not know that these are compromised hosts or these are compromised packets, so it will simply try sending them or try servicing them, right? So in that case, what happens when these legitimate nodes, okay, when these legitimate nodes actually try to send some request and want their request to be served, then the by that time the target server basically is overwhelmed and it will not be able to serve these legitimate users. So what is happening? The service that could have been given to these legitimate users is being denied, and that is why it is known as denial of service. Okay. So what do we do in order to avoid such issues? Okay. So there are many ways in which we can try to secure a communication. The first one you all know is authentication. Okay. That means identifying oneself as a legitimate host. Okay, so you have to prove yourself that you are who you are saying. All right, so what are the ways in which authentication is done? So in case of cellular networks, your SIM card has an identity in it. Okay, so that therefore acts as one of the identifiers for authentication. Okay. Now, next is confidentiality. Okay, so if you are sending some information and you do not want it to be intercepted, what do? You encrypt that message, right? So that anybody who, even if they intercept that packet, they will not be able to decrypt what is actually there in it. Okay, so via encryption, you can maintain confidentiality of information. The next one is integrity checks. Okay, so you can do integrity check of a particular data by putting digital signatures, which will basically detect tampering if there has been some tampering with the data. Another is access restrictions, which is basically with the help of using password protection. And the last one is firewalls, which are nothing but, so these are nothing but, acting as some middle box. Okay. So between your access network and the core network, there will be a firewall which will basically filter the packets which are coming into the network. All right. So what it will do, it will whatever packets are coming into your access network, it will simply filter the packets depending upon whether the packet is actually a um, compromised packet or it is actually a legitimate packet. Okay, so in case suppose you are having a DOS attack and there are a large number of botnets which are sending illegitimate packets into your server, so that it essentially lead to, so that it essentially leads to denial of service. So in that case, what would happen, that the firewall basically checks the packets which are incoming, and if it finds out that um, there is a possible attack that is happening, so then it will simply try to filter out those packets so that denial of service can be avoided. Okay. Okay, so there are many more security issues that are there. So we'll take a look at them later. First, let us see that how the network actually works. Okay, until now, what we found out, that what are the features that we need to look at, what are the metrics that we need to look at when we are talking about computer networks. Okay, so today we are going to look at that what is happening inside the network. All right. So basically, we need to know about protocol layers and network reference models. Okay. So what have we come to know by now is that network is basically consisting of several pieces, right? What are those pieces? You have network hosts, you have routers, you have different links which which use different transmission mediums. Then you have different applications, you have different protocols to control them, and different protocols to carry out the communication. And of course, you have different hardware and software. So these are different parts that are basically a composition of a network. Okay. Now you have a large number of pieces here. All right. So what can we do is we need to see that whether we can organize the network or not. Okay. So the question that arises is that why do we need an organization, and why do we need a structure of the network? So let's see. We have such a huge number of routers, hosts, different mediums, and different protocols will be there for carrying out communication at um, different steps of communication, right? So just imagine how much of task is to be done when there is a communication happening from just one device to another device. Okay. So in order to control all of that, in order to ensure that the communication is happening in a um, structured manner, we need layering. Okay. So we are basically designing a very complex system. So what you do when you write a very complex program, you try to do it in a modular way, right? You try to write modules, and then you try to link all of them together. That's what you do when you are writing a very large, very complex program, right? Same thing is happening here also. You are trying to do a layering part here because you are trying to design a very complex system. Okay. So why do we need this layering? So because it allows identification and also shows an explicit structure which will show the relationship of different pieces that are there in the system. All right. So we will see the reference model for this, that is in the later slides. Now layering is nothing but modularization. So why do we need this modularization? As I mentioned earlier, because it will help us in maintenance and updation of the system. Okay. Now there will be, if there is a change in layer service implementation, then it will be transparent to the rest of the system. That's also is required for us. And now let's see what is the protocol stack. Okay. So now this is very important. Please note this, and please pay very much attention on this, because this will be required for throughout the rest of your life. Okay. If you are trying to work in computer networks, even if you are not, still it will be required. All right. Now let's see. What is the layered internet protocol stack? So this is known as the protocol stack, internet protocol stack. Okay, it has 5 layers. We name it as the first layer is application layer. I'm going from top down. All right. Application layer, transport layer, network layer, link layer, and physical layer. Okay. Each layer has specific functions associated to it, specific protocols associated to it, and the tasks that it does, that is what we are going to read in this entire course. Okay, so how this course is designed? Until now, we have just read about, how the internet works, what are the basic parts of the internet, what are different access networks, what are different physical medium. So we have just learned that. Today we are going to, from now onwards, we are going to see each of these layers. What are the tasks of each of these layers? What happens to data in each of these layers? That's what we are going to study. Okay. So first let us see on a very high level that what happens in this layered internet protocol stack. So the basic tasks that the application layer supports are basically network applications. Some of them which you may have known are HTTP, IMAP, SMTP, and DNS. We will read all of them in the next chapter. So I'm just naming them right now. Okay, so HTTP, IMAP, SMTP, and DNS are some of the protocols that application layer will support. Then we have transport layer. Okay, so transport layer supports process to process data transfer. Okay, so you have a host or a node with you, and there is another host at another end of the access network. Now, if you want to communicate with another host, you can say that, okay, if I know the telephone number of somebody else, I can anyways talk. That's great. But we are talking from the point of view of different applications. Okay, and in each host there are several applications that can run at a time. Okay, so what you need to do, you need to identify that which application is actually communicating with which application at the other host. All right, so for that reason we need to have process to process data transfer, and that is supported by the transport layer. Okay, so TCP and UDP are some of the protocols which help to support process to process data transfer, and we will read about them also in the transport layer. Then the next one is network layer. Network layer basically helps in routing. Okay, so that means finding the path from your host to the destination. Okay, what path the packet should follow from the host or the source to the destination. So these are the some of the features. This is one of the features that network layer protocols that network layer supports, and the supporting protocols are IP and routing protocols. We will study these also in the chapter on network layer. Next is link layer, or it is also known as the data link layer. So data link layer is basically responsible for data transfer between neighboring network elements. Okay, so one of the tasks that data link layer helps us to determine is that suppose you are using a shared resource. So in that case, how each of the hosts that are connected to this resource, how they should access this um, particular resource. That schedule is determined. There is a protocol that the link layer provides in order to determine the schedule. Okay, by which the hosts are actually going to access the shared resource. Okay, so this is an example I'm giving. There are other tasks also that the link layer does, and some of the associated protocols which are there are Ethernet 802.11, that is Wi-Fi. But yeah, there are several versions of it, so this is just a simple way of talking about Wi-Fi here. So 802.11 is the standard for this, and we have point-to-point protocol, that is PPP, that is also related to link layer. And the last one is physical layer. Okay, so physical layer functionalities basically support the way in which your data will be actually transmitted over the physical medium bit by bit. Okay, so how the data is actually getting transferred over the medium, that's what the physical layer deals with. Okay, so let us look at what happens. All right, so this is your source system and this is your destination system, and each one of them have these 5 layers associated with them. Okay, for communication they have these 5 layers associated with them. Now let's see what are the, so see, these are the protocols basically from application to physical layer. These are the set of protocols that are required for sending even the smallest bit of data. Okay, so let's see what happens. So the first part is the application layer. Okay, so application layer is responsible for exchanging messages. That means you implement some application services in your system and you are sending some messages from your system to another system. So the application layer is basically responsible for one, creating this message and then sending this message over to the next layer so that that message can be further transferred to the destination. Now you can ask me something like, why there is a arrow in both the sides. It seems like they are connecting directly with each other at the application layer. No, that is not what it suggests. It simply says that this layer basically tackles data in the form of messages. Okay. Now, your message, that is this part, M. All right. So this is now transferred to the transport layer. Okay. Now the transport layer, what it will do? See, when you are, just imagine a scenario that you are sending a letter to somebody. Okay. So the message is actually the content of your letter that you have written. Okay. Now what you need to do, you need to put that letter in an envelope. Then you have to stick that envelope. Then you have to write the addresses. Okay, to and from, you have to put a stamp and then you have to post it in the letterbox. That comes the last step for the source. Okay, so same thing is going to happen here also. Okay, so you have the message with you. When the message comes at the transport layer, then there are certain information that needs to be attached to this particular message so that it can be easily intercepted at the destination side. Okay, remember the transport layer, as I told you in the last slide, that it is responsible for process to process communication, right? So it does have to give some information to the destination, that what process does this message belong to. Okay, so this is one example, just I am giving for your clarity. Okay, so this HT has that information. Okay, along with some other information also, but for now that HT has that information of the process to which it belongs and the process to which it needs to communicate to. Okay, so the transport layer protocol transfers M in a reliable manner from one process to another using the services of network layer functionalities. Okay, now this HT and M, right? So now you have the entire packet that is having your message M and the header HT. Okay, this entire part, that is known as the segment. Okay, so at the application layer, you had the data as a message. At the transport layer, you added information in the form of HT, that is a part of the header, and then you call it as a segment. Now, once the segment is ready, then you send it to the network layer. Okay. So now you are going back to the network layer, going forward to the network layer. So here also you have some extra functionalities that you need to add, right? That means some information you are adding so that it is easier for the host, I mean for the node at the destination to intercept as to what you have sent and what is it relevant to. Okay, so network layer protocol is basically responsible for communication between any two hosts. Okay, so what do we know? Network layer protocol basically gives the routing information. That is one information that we know, right? So the HN part is basically giving or having all the features or all the information that are required for the corresponding network layer at the destination node. Okay, so we had a segment at the transport layer. We had a segment at the transport layer, and now after adding the network layer information, that is HN, to the message to the segment, we have a datagram. Okay, so at the network layer from segment, when we add extra information onto the segment as header, then we get a datagram. Okay, now this datagram is further sent to the link layer. All right, so here it is written that you add the HN to create a network layer datagram. All right, now we get to the link layer, okay, or the data link layer. So what does the link layer do? So the link layer is basically responsible for communication between with the host and the neighboring hosts, right? So that is the data transfer protocol that will be required for communication among different hosts. Okay, so for that also you have added a certain information that will be required at the destination's end, and that is given by HL here. So once you add this information, then it becomes a frame. Okay, so you had a message M, then you went to the transport layer from the application layer. That is, the message was passed to the transport layer. Information was added on that message. It became a segment. You send that segment further to the network layer. The network layer adds some information, makes it a datagram. Then again forwards it to the link layer, and then the link layer adds information to it to this datagram and makes it a frame. Okay, all right. Now after this is created, let me just go back once. Yeah. So this is what I was talking about: message, segment, datagram, frame. Now the same frame goes to the physical layer. There you have protocols which will help to transfer this information, this frame, over to the medium bit by bit and then send it to the destination. All right. So this is what is going to happen. Now you have take a look at the frame that you are having. Okay, that is from the link layer you have sent it over the physical layer, and then you get this as this frame at the link layer of the destination. Okay, so I was giving you an example of letter posting, right? So what was done? So until here, until the physical layer of the source, you have posted your letter. Basically you have just dropped your letter into the post office. Okay, so now this part, that is how the letter is how the data is getting transmitted from the source to destination, that's not your headache, because you are the source. That is the headache of the post office and how the communication happens there. Okay, so it is their headache to send it to the destination. So that's what is happening. Okay, so here it is the responsibility of the network to send this information. The physical medium is responsible for it. Then after it reaches the destination, okay, so once your friend receives your letter, what will your friend do? Your friend will first check the um, cover of the envelope to see where is it from. Okay, then your friend will basically open the envelope and then they will read the letter in the end. Okay. So until now, what was done at the source? At the source, the actual message was encapsulated to a frame. Okay. From message to segment to datagram, then to frame. So encapsulation was done. Once it reaches the destination, there will be a decapsulation, right? So see here you have a frame at the link layer. So part by part, you are just pricking it and seeing that what the actual message is at the application layer. Okay. So again, at the link layer, it is a frame. You basically get that information at the link layer. Then okay, fine, done. Remove the information. Send the datagram to the network layer. At the network layer, read that information. HN. Okay, remove that information. Becomes a segment. It goes to transport layer. At the transport layer, read the information what was there that is HT, get that information and then send the actual message M to the application there. Right. So this is how your encapsulation and decapsulation happens. So let's see what happens here. All right. So there is a source. We have a switch and a router in between in the network, and you have the destination node. Okay. Now I think you can ask me a question, otherwise I will ask you a question. See, there are all the parts of the five layers here at the end systems. That means the source has all the five layers, the destination has all the five layers. But take a look at the router. The router has only three layers, and the switch also has only two layers. It does not have all the layers. So can someone tell me what is the reason behind this? We should ideally we should have all the layers for all the systems, right? Which are there in the network. Why are we having some layers in some hosts and all the layers in some hosts? Why is that so? Can anybody answer this question?
Ma'am, so that they don't take out our message in between.
I mean that is okay, but then any other host, how will we know that suppose there is a hacker in the system? Okay, so the hacker is also a particular host only. He is having all the five layers, isn't it? Any other answer?
Ma'am,
Hello,
because
ma'am.
it's needed only the
Uh,
there are no
one by one.
messages.
Can you repeat what you said?
Ma'am, maybe because it's not needed. We do not need the application or transport layer because there are no processes or applications running on the router. Only hosts and destination generate applications or processes.
Yes, yes, correct. What's your name?
Ma'am, Anirudh.
Anirudh. Okay. So yeah. So what Anirudh said is correct. So see, if you recall what was taught in the first classes, we had seen that the end systems, it is written in the slides. If you go back and then you will see applications run at the end systems. Okay, your mobile phone has applications, your laptop has different applications. Okay, your desktop has different applications. But what is the need for the router and switch to know about these applications? Because their task is to simply forward the data. Okay, forward the data, that is forward the data to the correct path or send the data to the right destination, right? So that is their task. They are not running any applications in them. Okay, so that is why all of these five layers are not needed in these two systems, that is switch and router. Okay, so let's see what's happening. So the message was there at the application layer. It is now forwarded to the transport layer at the source. Then once it goes to the transport layer, extra information is added as header and it becomes a segment. Next, this segment gets to the network layer. Information is added. It becomes a datagram. It goes to this datagram is going to the link layer. Information is added, becomes a frame. Okay. Now what will happen? At the physical layer, this frame will be transmitted from this source over to the network. So that's what is happening. Okay, this went very fast. All right. So from there, it went to the switch. Okay. At the switch, what are the two layers? Only the physical layer and the link layer. Now, okay, is my mouse visible? I hope my mouse is visible to you. So just take a look at this, just the red line, okay? So it could have simply shown that the data is just going directly to the switch and coming to the router. But what it is showing that it's coming to the physical layer, going up to the link layer, then again coming back from the link layer to the physical layer again. Okay. So why do we need this? Because when the data reaches the switch, first we need the physical layer in order to intercept the signal. And what do we need? We need to know that which port do we need to transfer the data to, right? What is the schedule with which this switch can transfer its data to the medium? That is why we need the link layer information. Okay, so you took the link layer information, saw that okay, we need to forward the data to the particular port, and then again, so you just half opened the envelope and saw just a little bit of okay, what is the source, what is the destination, what is the next post office that I need to send. So you covered the envelope again, sent it over for transmission to the next post office. So that means the switch took the information and then again encapsulated the data and then sent it to the router. Now at the router also we have the physical layer. So the data reached at the link layer, we have the frame, we got the information. Then there is network layer. Okay. So at the network layer, we have it as a, what do we have it as? We have it as a datagram, right? So then at the network layer, that information is intercepted, that what was the corresponding network layer information sent from the source. Once this information is intercepted by the router, then the router again sends the packet to the correct path. It is encapsulated again and then it is sent to the destination. Okay, so after it reaches the router, so okay, sent it to the network layer. I've already finished. Okay, then from the network layer goes to the link layer. Then from the physical layer, it is transferred to the destination. Again, at the destination, what will happen? We will have decapsulation here. So that means read the link layer information. So this is a data, sorry, this is a frame right now. Then as a datagram goes to the network layer as a datagram, read the information that was added for corresponding to that, goes to the transport layer as segment, read the information that was at the header, then as a message to the application layer. Okay, so this encapsulation and this overview of end-to-end view basically of how data is transmitted from the source to the destination, that is very important. Okay, so if you can remember, it's not about remembering, if you can understand, if you can understand what is happening in this, then half the job is done. Okay, you need to very clearly understand that how data is transmitted. Only then we will understand what are the different protocols that are there in the application layer, in the transport layer, etc., and how they are working with the message that is being transmitted. Okay, all right. So yeah, so then we have the history of network. So I am not going to the history of network. This is simply, what happened between which year to which year. So this I will give you the slides. You can just go through the history. Okay, if you're interested, you can just go through the history of the internet. It will be helpful for you. You will get to know how things worked out. And there are some extra slides also here. Let me show you at the end of it. Okay, so okay, there's a lot of history here. Okay, let me hmm. See, these are some additional slides which will simply say that okay, uh, what we just now studied is 5-layer protocol stack, right? IP protocol stack with 5 layers. So there's another reference model which is known as ISO or OSI reference model. Okay, so this OSI reference model has extra 2 layers. Okay, so those are basically the presentation and session layer. So they support applications like encryption, compression, and the session layer supports applications such as synchronization, checkpointing, etc. So in the current version, that is the IP protocol stack, these tasks are already embedded in the application layer. Okay. All right. So this is about Wireshark. So this is just an example. You can take a look after the class. All right. So now let me just start the next chapter. Okay. So in this chapter, we are going to study about application layer, the corresponding protocols, and the tasks that it does. Okay. So this part, let's skip to the right one. Okay. So what happens in the application layer? Okay. So what we got to know about the application layer, that it is basically responsible for servicing different types of applications to users. Okay. So when we say application layer, we are talking about different types of protocols which which belong to the application layer and which help in supporting different applications that the user wants to work with. Okay. So some of the protocols, okay, some of the protocols are HTTP, SMTP, IMAP, DNS, okay, video streaming applications, CDNs, etc. Okay, so we will see all of these. Some applications that we are, that are supported by the protocols that we are going to study are, social networking applications, web browsing, text messaging, email, multi-user network games, streaming, etc., and P2P file sharing. Okay, that means point-to-point file sharing. We have voice over IP, we have real-time video conferencing, we have search, remote login, and so on and so forth. Okay, so we have a large number of network applications that we need to support. So if you think about it, if you have so many types of applications, how many number of protocols will be there if we simply consider that each application has its different type of protocol? Okay, so we have to come up with some kind of protocols which can be used, okay, in order to support these applications. All right, so let's get to work. How does it work? Okay, so application layer protocols. What have we learned by now? Application layer protocols will be there only at the end systems. That means you have it in your end systems of your network. Okay, end hosts. All right. So these applications are basically communicating over the network with different hosts. All right. So what is an example? So an example given here is that your web server software communicates with your browser software. All right. Now, so all right, fine. So when we are talking about, how data is being transmitted from one layer to another layer and then finally to the destination, that's what we have studied in the encapsulation. But what we are going to see in this chapter and in the other chapters also, so we will look at it in the way that data is basically being transferred from the application application layer to application layer itself. We will not look at what is happening at the transport layer, network layer, data link layer, etc. Okay, when we are talking about something in one chapter, so we are talking about application layer and its corresponding protocols in this chapter, right? So we will see what is happening at the application layer, or what are the protocols and what does the protocol do at the application layer of the host, and what does the protocol do at the application layer of the destination. That's how we are going to see it. Okay, we are not going to see that what is happening after the data is being sent to the transport layer. That we will deal with in the chapter corresponding to transport layer. Okay, so please don't get confused that we are directly sending information from application layer to application layer. It's not like that. Okay, all right. So I was asking the question in the last slides that on encapsulation, that why don't we need the other layers in case of routers and switches. So the answer is here, that and it was told also correctly by Anirudh that network core devices do not run user applications, and therefore we do not need them. Okay, we need them only at the end systems. Okay, now, so you want to transfer data from one host to another host. Okay, so there are two different paradigms that are used for this transfer. Okay, one is known as the client server architecture or client server paradigm. Okay, so here what happens? One host will work as the client, another host will work as the server. Okay, so who's server and who's client? So server is somebody who can be requested for information by any client here, right? So basically, if you are Facebook server, suppose, so in that case, users users will be clients, and they will be accessing for information from the Facebook server. Okay, so the server will be it will be required for the server to always be on. Okay, that means the server should always be available for communication whenever a host asks, right? So that is one requirement. Okay, that is one requirement for a server. It should have a permanent IP address. That means you should have a permanent address, so that the hosts can actually communicate with you easily. Okay, if your IP address keeps changing, if the server's IP address keeps changing, then it will be difficult to actually find out that what is the IP address of the server for any host which is trying to transfer its information. Okay, now server can also be a data center. All right, now next is client. Okay, so what are the features of the client? So client is the one who basically contacts the server and tries to establish a communication with it so that it can get the information that it wants. Okay, now of course it is not necessary for the client to always remain connected with the server, because it it does not need the information every time, right? So it can be intermittently connected with the server. Now as far as the IP address goes, it may not have a permanent IP address. Okay, so that it can have a dynamic IP address as it has been written here. So why do we go for a dynamic IP address and all that, we will also study in the network layer chapter. Okay, so we can have dynamic IP addresses for different hosts. Now again, next part is that clients, they do not communicate directly with each other. Okay, so that's what has been given here in the figure, if you see. So there are two hosts which are trying to communicate with the server. Okay, so even if they want to communicate with each other, okay, even then they cannot communicate directly with each other. There has to be a server in between that will act as a gateway. It will take the information from the host, from the source host, and then send it to the destination host. Okay, so an example I'll give you about this is your mobile phone networks. Okay, if you want to call your friend who's sitting right beside you, It will not go from the communication will not go from your phone to your friend's phone directly, even though you are sitting close to each other. It will go to the nearest base station. There, the information will be intercepted. It will be found out, okay, what is the destination address to which you want to communicate, and then the call will ring or the phone will ring at your friend's mobile phone. Okay, so this is an example that I am giving you regarding this last point, that clients do not communicate with each other in a client server paradigm. Okay, some of the example protocols that follow the client server paradigm are HTTP, IMAP, and FTP. We will read about that in this chapter itself. All right. And the next one is the peer-to-peer architecture. So in peer-to-peer architecture, you do not have the concept of server or client. Whoever wants to communicate with another host, they can communicate with them directly. Okay, so everybody is a peer, right? So you need not have a server which is always on, right? Next is that any end system can directly communicate with any other end system. So if there is a device that wants to connect with another device, they will directly send the request to that device, and the other device can return that information. Okay, so what does it provide? It provides self scalability. That is, new peers will bring new service capacity, as well as they will also bring new service demands. Okay, so these peers can be intermittently connected. Okay, and they can also be having dynamic IP addresses, right? Because we know that end systems can be intermittently connected, and they can also have dynamic IP addresses if they are not servers, right? So if you have such a system where the address keeps changing and they are not connected always, so then communication becomes very complex, and the management of these communication also becomes very difficult. Okay, so these are some of the uh, disadvantages that we have in case of peer-to-peer architecture. Okay, one of the example of peer-to-peer architecture is P2P file sharing. So that is basically point-to-point file sharing between two devices. All right, so yeah, running out of time. So fine, the class has ended now. If you have any questions, you can ask me.